For decades, NASA researchers have helped refine our understanding of hurricanes and tropical cyclones. Among their tools are computer models that can help distinguish the roles played by sea surface temperature, pressure, and wind speed. These model studies show that what makes a busy or slow Atlantic hurricane season largely relies on 3 ocean patterns. These 3 factors contribute to either a strong or a weak hurricane season, each acting a little like an on-off switch. First, the El Niño Southern Oscillation's 2 phases, El Niño and La Niña, affect sea surface temperature in the Pacific Ocean, which then alters wind strength in the Atlantic. During El Niño years, Pacific sea surface temperatures near the equator are generally warmer than average, which drive winds that shear the tops off hurricanes, making it harder for them to form. Cooler Pacific water during La Niña years creates more favorable hurricane wind conditions. The North Atlantic Oscillation's 2 phases, positive and negative, describe the difference in pressure between 2 poles of a pressure system, low pressure near Iceland and high pressure near the Azores Islands. When the pressure difference between them is lower than average, hurricanes are more likely to form. When the 2 pressure systems are more intense than average, wind conditions are not conducive to hurricane formation. Further south, the 2 phases of the Atlantic meridional mode describe sea surface temperatures, either warmer or cooler. When the area north of the equator is warmer than average, hurricanes are more likely to form. When the same area is cooler, hurricanes are less likely to form. Together, these factors can make or break a strong hurricane season, and understanding how they interact can help better predict the number and strength of hurricanes seen throughout the season. For example, in 2005, the Pacific sea surface temperatures were average, so the El Niño Southern Oscillation played very little role. The North Atlantic Oscillation was mildly negative, which influenced winds more favorably for hurricanes. The Atlantic meridional mode was the strongest influencer this season, with very warm Atlantic water temperatures leading to a busy and powerful hurricane season, which included hurricanes Katrina, Rita, and Wilma. In 2013, the El Niño Southern Oscillation favored hurricane formation at the beginning of the season, with a weak La Niña contributing cool water in the Pacific, a neutral Atlantic meridional mode, and a negative North Atlantic Oscillation setting up favorable hurricane conditions. However, in mid-July, the North Atlantic Oscillation suddenly changed to a strongly positive intensity, creating unfavorable wind conditions and limiting hurricane formation in the Atlantic.